Hi guys, welcome to a new video of calculus. Today what we're gonna learn is derivative rules. So as a reminder, what I'm gonna do here is gonna put everything that we have done in the previous video. So if my f of x equal to x to the power of n, my derivation of that is gonna give us n x to the power of n minus 1. If I do f of x equal to c, my derivation of that is gonna give me 0. And our special case right here, if f of x equal to e to the power of x, and our derivation is gonna equal to e to the power of x. Okay, so far this is what we have learned. So let's do some derivative rules. The first and easy one, we already have seen this. I kind of impose this kind of rules in my previous video. But right now we're gonna go deep down into the rules of it, how to prove it. So if I want to find my derivative of g of x plus h of x, I'm gonna have to start from the start, right? To start again. So let's do limit as h plus 0 f of x minus f of x plus f of x plus h minus f of x divided by h. Let's just replace our let me make some space first. Yeah, let me make some space. All right, so let's do the limit, shall we? So I'm just gonna put g of x plus h plus h of x plus h in whose parentheses that shows that this is like f of x plus h right here, minus g of x plus minus, or you can say huge parentheses here, h of x. My minus is gonna distribute inside my parentheses. So in order for me to open my parentheses. So if I open my parentheses, this is my g of x, h as x plus h minus g of x divided by h right here, plus h of x plus h minus h of x. If I separate this into two fractions, excuse me, I'm gonna get something like this. Right? And this is gonna be plus. This is plus or minus. Okay. Okay. The reason why I put plus or minus here, because it can be a plus or a negative, doesn't change the rules. You just change the sign. So you guys don't have to worry about the sign right now. So alright, so we got g of x plus h minus g of x divided by h plus or minus h of x plus h minus h of x divided by h. We learned that in my limits rules. That's the reason why we learn limits, right? I can distribute my limits inside. H. This is a minus sign. Alright, so does this equation remind you of something? Does it? I hope it does, because oops, just write f of x right here, minus, right? If my limit as h approaches 0, for f of x plus h minus f of x divided by h, I'm getting my derivation for f prime of x. So if g of x plus h minus g of x divided by h, what is that going to give me? It's going to give me g prime of g. G prime of x. G prime of x. Whatever. Right? G prime of x plus the same thing with h. It's going to be h prime of x. So f prime of x equals g prime of x plus h prime of x. This is my distribution rules when it's addition or subtraction, right? It doesn't matter, the rule stays the same. All right, now let's go to another. Let's go to another rules. F of x equal to h of x times g of x. Let's find out the rules for that. So as you guys should know, just gonna write the derivation limits right here. I'm just gonna write this equation for you guys to not to forget. This is very important. We're gonna be using that to prove rules. All right, so I'm just gonna give you a hint. What we want in this video is to generate an equation like this at the end, right? No matter what. So mathematics has a lot of tricks, and we're gonna be using some tricks, but we're gonna be using some tricks to reach a conclusion that's gonna give me a format like this, right? I want to be able to find h prime of x and g prime of x somehow. So let's get going. So let's put my limit right here. Times g prime of x. I just plug in my h plus h, and that's it. I hope so far you guys are not confused, but I hope everything is going smooth for you guys. So this is when I plug in my h plus x plus h inside of my function h of x and g of x. So all right, right now, if you guys were gonna try this alone, you're not gonna succeed. Trust me, this is not something easy. So the thing that I'm gonna do is I want, if I want to read something like this, I want to be able to factorize my h of x plus h. I want to factorize this and this, but I can't do that right now. I can't just factorize it. So what I'm gonna do is I'm gonna add h of h x plus h multiplied by g of x, g of x minus that again, right? Plus h of x plus g of x. Okay, so divided by h right here. So what I can do is I can how do I say this? I can factorize my h of x plus h of x plus h. Yes. Right, so let's do this. One thing I want you guys to know is that this is not related to h prime h of x. Okay. Okay. My h of x is like a different function. Okay, when I say So this is not equal to h. Okay, just be careful of that. My h prime of x could be any. I could have just z prime z of h z of x plus h. Right now I have chosen h. What my h represents, it doesn't matter. Okay, my h represents a function and my g represents another function. For example, my h can represent x to the power of 2, and my g can represent x to the power of 3. For example, I just want to make this clear enough. Alright, so let's do this. What I can do is factorize my h of x plus h. Factorize it. What I get is g plus h plus g of x. Okay. It's all divided by h right here. And let's look at this. The same thing here. I can factorize my g of x. Now you see where this is going, right? And did I made a mistake somewhere? Oops, no, this is still the same. Made a mistake. Sorry, guys. So just gonna erase that. This is gonna be plus. This is gonna be minus right here. Yeah. So hold up. I'm gonna erase that and write it. I'm just gonna rewrite it again because this kind of messed it up a bit. All right, so let's do this. What I'm gonna do is just gonna put that. Just gonna rewrite it again. I'm just changing the position. That's it. Because I'm going back here. You see, there's a negative sign. I want a negative sign. I don't want a positive sign. If there's a positive sign, I can't find the derivation. So, yeah, I'm putting a negative sign here because of this. Right. This time, if you look carefully, what I'm finding here, if I factorize my h out, my h plus x, my h of x plus h, I'm gonna get it's a derivation of g of x, and this is gonna be divided by h right here, and this is gonna be plus h plus h of x, g of x, minus h of x, g of x. Right here, we have a negative sign, negative sign. That means that I'm gonna find my in here, my second part, I'm gonna find the derivation of my h of x. Let's just write it here. I'll just factorize my h of x, my h of x plus h here. So I can get g of x plus h minus g of x. When I factorize h of x plus h, I'm going to be plus. Going to be plus a factor because I factor. Let me just remove that. I factorize my g of x, and what is left beside is h of x plus h. H of x plus h minus h of x, right? Divided by h. Now let's separate all of these into fractions. Plural. plurials, right? It's my h. I'm gonna write in a way so I can get a similar format as this one, right? Remember, when I'm doing my proof, I want to reach something that resembles this, right? Look at where my arrows are. I want to reach a proof that reaches a kind of conclusion. And my g of x is outside right here. All right, I'm gonna use my limits law to put in my limits inside of my function right here. So limit h approach 0. What I'm gonna do right here, I'm gonna put this in front of here. Actually, no, we do that later. Okay. Yeah, make a mistake somewhere. Yep, nothing. Sorry, just checking if I made a mistake. Okay. All right, so let's continue. This is just I'm just gonna. It's very like slow. I'm going very slow, but I'm making sure everything is correct, and at the same time, you guys are following me. I hope, right? So here I just use my limits law to distribute my limits inside here. All right. Here I'm gonna use my limits law for the first part to evaluate this and this. So let's do this. H of x. Okay. So limit h approach 0 h of x plus. So this is like my limit law that I'm using, right? So I'm just gonna put this here. Limit h approach 0 for x. H time h to the power of h is going to be equal to limit h approach to 0 h time limit h approach to 0 a to the power of h. Okay, I can do that for my limit. Okay, so this is what I'm doing here. And I hope you guys are saying that this resembles the derivations equation, right? Yeah, so let's do this. And here I'm gonna put my g of x outside of my limit. Okay, this is an edge. Here, if I evaluate my limits for my h of x plus h, I'm gonna get h of x. The reason for that is, let me just take any function, x to the power of 3. Let's take x plus h to the power of 3. Well, I'm plugging my age. My age goes to 0. It's going to be just x to the power 3. How about a radical function? A rational function. Like x to the power of 2 plus h. No, x to the power of 2 plus 1 divided by x to the power of 3 plus 1. So plugging in h right here. X to the power of 2 plus h to the power of 2 plus 1. And x to the power of x plus h to the power of 3 plus 1. Let's take like minus 1 here. Just to get something, right? There's minus 1 right here. So we'll have like a vertical asymptote, but that's not important. So if I just plug in 0 here, I'm gonna get the same thing, right? So when my limit h approaches 0, for my function h of x plus h is going to be equal to h of x. This is just going to give h of x times limit h of approach 0 g plus h minus g of x divided by h. However, if you see if I plug in my h my 0 inside my g of x plus h minus g of x divided by h, I'm gonna get an undefined form. This is what I'm gonna get. So I can't just do what I just did with this one. So and plus we already have proven the derivation law, the derivative in my other video, right? I hope you see this is resembling something. Right? You're gonna like this look like something. Tell you what, try to write the final answer on your own. Try to see if you can guess what it is. If you guys guessed it, you guys already good at calculus, right? So if you already have guessed it well, you should get something like h of x times g prime of x plus g of x times h prime of x. This is my product rule. Right? Good news, you guys don't have to do all of those steps in in exercises. The goal is not to test your amazing mathematics high IQ skills. Your goal is to try to see if you understand how you guys should use the product rules, right? We are interested in the final answer right here. This is my rule, right? So let's write it again. f of x equal to, let's do this properly. F of x equal to h of x times g of x. And if I do the derivative of that, I'm gonna get h of x times g prime of x plus g of x plus g prime of x, h prime of x. Okay. So far we have seen two type of rules, and I'm gonna give you guys an example of this. Okay. So let's do an application of what we just done. Okay. I'm gonna write. Oops. Okay. Let's write the rules right here. Let's just actually let's write it more neatly, be a bit more organized. G of x, g of x times h prime of x. This is about derivation rules, and I'm gonna give you an example. So let's take 2x 2 to the power of x to 2 times x to the power of 2 times x to the power of 3, and find out the product. So find the derivative. Actually, I'm having difficulty to pronounce it. Okay, so let's try this again. Find the derivation. Okay, so this is my h of x. This is my g of x. All right, so let's derive it. I know in my function I just need to plug in, right? G 2 times x to the power of 2 times the derivation of g of x is going to be 3 x to the power of 2 plus, now g of x is x to the power of 3 times derivation of x prime of x. So x to the power x of x is 2 times x to the power of 2. Derive that, I'm gonna get 2 times 2 times 4 times x to the power of 1, right? So here I'm just gonna simplify it. So 2 times 3 is gonna be 6. Here's gonna, and we're gonna, and here it's gonna be 2 x to the power of 2 times x to the power of 2 is gonna give me 4 plus, here let's simplify this one. Here's gonna be 2 times 2 is gonna be 4 plus 4 x to the power of 3 times x is gonna give me x to the power of 4, and final answer is 10 to the power of x to the power of 4. Right. So this is the product rules. This is the first way of doing that, and there's a way. I could just simplify in the beginning, right? Now let's do simple product rules. Let's do simple derivation. Okay. Time here is gonna be my 5 is gonna go in front. 2 and 5 x 5 minus 1 right here. I'm gonna write it slowly for you guys, and x to the power 4. This is product rules, right? So the reason why I did 2 ways right here, I could just simplify and do the derivation easy, right? This is easy. Okay, and the reason why I'm doing the product rules right here is to prove you that the product rules does work. Now let's do another example of the product rules that you can't do the other way. You must use the product rules. Okay, f of x equal to 2 of x times e to the power of x. Now we learned in the previous video the derivation of x of the derivation of e to the power of x is e to the power of x. Gonna confuse right here. So let's define this. This is gonna be my g of x. Let's actually write my function again right here. All right, so now let's derive. Okay, so my 2x represent my h of x, and my e to the power of x represent my g of x. So f prime of x is gonna equal to, let's plug in h plus h of x. H of x is 2x, right? 2x. Now we're gonna use a derivation of g of x. So the derivation of g of x is gonna give us e to the power of x, which doesn't change, right? It's gonna be plus. We plug in g of x, e to the power of x, and the derivation of 2x, which is gonna give us 2, right? So basically 2 here. This is my constant. Oh, I forgot to write a rule. Forgot to tell you a rule. You know what? I'm gonna tell you after this. I should have told you a long time ago. Whatever. Okay. That's on me. So so can you just simplify it right here? Plus 1. This is my answer for my product rules, for my derivation. And I just want you guys to know that if I have x, f of x equal to c of x right here, x to the power of n, my f prime of x is going to equal to c times n x to the power of n minus 1. Okay, so this is my derivation rules that you guys should remember. I'm going to write a lot of rules for you guys to remember. There's a lot of rules that we guys have to remember, unfortunately. Final rules. Gonna be quick, guys, don't worry. Let's do another rule. This time we're gonna be using what's happening. Okay. This time we're gonna use focusing on quotient rule. Right? Let me see something. Yeah. All right. So same thing. Nothing changed. We write the derivation rules. And the rule is the equation. Right? So this is h right here. Okay. And I made a mistake again. This is supposed to be minus. God, me and my sign. Okay, now let's use this equation to find my derivation of my quotient rule, for my quotient rule. Okay, so my f prime of x is gonna be equal to limit h approach to 0. That's right. Well, I'm just gonna plug in my h plus x plus h inside my function. All right, it's gonna be minus g of x divided by h of x divided by h. Oof. So now let's do what we usually do. Let's simplify. This is what limit is all about, right? Do you remember when I told you in my problem video about limits? It's always about simplifying, conjugation, or factorization. If you know how to do one of those three conditions, one of those three tricks to do the limits, you're set for most of the time. Most of the time. There are other tricks that you guys have to learn, but for now, this is it. Right, so what we must do is put my numerator, we have like two fractions in my numerator. I want to put those two fractions to have same denominator. So right here I'm going to multiply times x, h times h of x, h of x right here. And here I'm going to multiply by h, x plus h times h of x plus h. I'm just gonna write it quickly right here. So it's gonna give me this. Okay. So that if I plug in, if I look my numerator, it's gonna be h of x times g of x plus h. Do I have no space? Yes, I do. Minus g of x. I'm gonna write it in an even bigger right here. Gosh, there's a lot of things to write. Okay. So in my top is gonna be h of x times g of x plus h minus g of x times h of x plus h divided by h. And remember, guys, what we need to do. Same thing, right? So for now, what I'm gonna do is put my h, evaluate my h. Where I'm gonna put my h, right? Where does my h go? So let's assume AB divided by C. My AB is my fraction, obviously. So when there's a fraction in my numerator, my C is gonna go time to multiply to B. But if there's a fraction in my denominator, my C is gonna multiply times A. Right? Same thing here. Let's see. My fraction is in my numerator, so my h is gonna multiply to my to h of x times h is gonna multiply times h of x times h of x plus h, such that we're gonna get something like this. Let's write it quickly. Alright, so this is my result, right? I hope you guys are not too confused by this. Right? So same thing, what we are gonna do here. Did I make a mistake somewhere? Just gonna see, just gonna run through it to make sure I didn't make any mistake. Nope, everything is good right here, so should not have any problem. Okay, so far this shouldn't be so far so good. Now let's continue. So you guys remember the first? You guys remember the first thing, the trick that we used in the product rule? We're gonna use it here as well. So here instead, what I'm gonna do is gonna be I'm gonna add f of x. Just single. Actually, I'm gonna subtract f of x. Doesn't change, but my organization matters to me. Can I say? So then I'm gonna add f of x times g of x. So in such a way that this is going to be equal to 0, right? So nothing really changed. I'm just manipulating in a way such that I can get an answer that contains a format like this. All right. So let's write over denominator. Wait, this is h. Right, let's write it quickly. Right, so what I can do is I can just rewrite my limits as I want. So here, and not, why did I write f? It's supposed to be h. All right, so I can factorize h of x. Then inside of my function here, I get, it's supposed to be subtraction right here. Right, and this should ring a bells, right? We are getting somewhere. Not quite, but we're getting somewhere. All right, now let's do the same thing here. This time we must factorize g of x. So let's factorize g of x. This time, yeah, let's see, this is gonna be. I'm looking if I'm making like, and I hope I didn't make a mistake. Yeah, yeah. What I'm gonna do instead, I'm gonna subtract minus g of x actually. It's going to be negative. It's going to be plus h of x plus h. So you see, the reason when I factor g of x minus g of x is to have my h of x plus h to become positive, and my h of x to become negative in order to have this, right? I want to get something like this. As this is my h of h prime. And this is so it's h of x plus h minus h of x divided by h. So h of x should be negative. So that's why I want my h of x to be negative, right? In my factor by doing my factorization. So as simple as that. I can just divide my limit into two parts. The first part, what I can do. Just gonna write it quickly again. Right, I have put my h of x in front of my limit. And I'm just gonna do this right here, minus g of x. And this is gonna be h times h of x times h of x plus h minus limit h of x. Actually, I'm gonna put out my g of x as well. So here I'm just gonna put this in front. So it's gonna be h of x plus h minus h of x divided by h of divided by h times h of x. If you need more space, times h of x h of x times h of x plus h. Let's continue. What I can do here, now I can just separate these two balls, right? So I can separate this and this, and same thing for here, right? I want to separate those two. So let's do this. I can divide my limit into two parts right here again, such that we're gonna have something like this. Divided by h times limit as h plus 0 for same thing right here. So this is going to be h of x times h of x plus h. Oof, this is going to take a long space. Minus g of x times limit h of x times limit h plus 0. My numerator, I'm just going to write this quickly. Right? And do my limit again. Right? The reason why I separate those two parts is to make it more organized. I hope you guys are not confused by this, right? This is basically my limits law again. I'm using my limits law where I can when two different functions are multiplying against each other, I can just separate those two by distributing my limits. Here, I distribute my limits between those two kind of functions. So here, as h equals 0, this is going to be h again here. So I'm just going to write it quickly here. I'm going to get h of x to the power of 2, because this is going to become h of x. H is going to equal to 0. So we are left with h of x times h of x. And we have this h equals 0 for g of x plus g of x plus h minus g of x divided by h minus g of x divided by h to the power of h of x to the power of 2. Remember the same thing here. My h goes to 0, so h of x plus h. When my limit of h goes to 0 is going to equal to h of x, which is going to type h of x again. It's going to give me h of x to the power of 2. And write the limit again. All right, there's a lot of things going on. There was a lot of things going on. So, where is this going? You're asking, Kavish, you have done such a long calculation. This is hurting my head. Why are you doing this to me? Well, it's to show you how mathematics are calculated. You guys don't have to do all of those steps each and every time, but it's to show you it's to show you how we got there and how limits are used to find new rules and why limits are important. This is what I told you guys. Limits are like the ABCD of calculus, right? You can't go writing sentences when you can't even know you can't even know ABCD. So you can't even, I can't even I don't want to show you the rules without even showing you how to guess those rules, right? So it's the same concept, right? So let's do this. Yeah, but h of x right here is going to stay the same. Same for h of x to the power of 2. Here is going to give me g prime of x minus g divided by h of x to the power of 2 time. Here I'm gonna get h prime of x. You guys could stop here if you want, but we want a more simplified version. So let's simplify this again. These are the same denominator, so we can just write this here. Like this. Okay? Just for you guys to know, this is not commutative. Okay? So I'm just gonna write it again here. So if my f of x equal to, do right here, yeah, g divided by h, g divided by h, my f prime of x is gonna equal to, I'm gonna take more space, h of x times g of x prime minus g of x times h of x. So when my h is at the bottom, is always h of x times g prime of x minus g of x minus h prime of x. In other words, you can't go switching that and that. Okay, you can't switch those two. It's not commutative. Just for you guys to be careful. Okay. So in other words, if you have, for example, z of x divided by f of x, it's always just z of x prime times f of x minus your z of x times your f of x divided by f of x to the power of 2. Actually, f of x to the power of 2. Right? So your function in your numerator is gonna be in the front right here. Okay. You know what? You guys just need to remember this equation, and you can just apply it, right? So this is my final rule that I'm going to show you. There's another way of solving complex derivations. It's called chain rules, but we're not gonna do chain rules in this video. We're just learning how to. We're just learning simple derivation rules. So so we have been through a lot, like a lot, and I hope you guys has a lot of patience in this video, because I sure don't. So let's write everything that we have done. Okay, so let's write every derivation rules that we have seen so far. F of x equal to x of n. If you do a derivation of that, I should write it next to it. X prime of x is going to equal to n times x to the power of n minus 1. X equal to c. Yeah, f prime of x is going to equal to 0. X of x equal to cx to the power of n. Your f prime of x is going to equal to c n times x to the power of n minus 1. Now, if what else? Yeah, f of x equal to e of x. You're going to get x prime of x equal to e of x. And here, I'm going to write something here. I don't want to prove it to you. I don't want you guys to. I don't want to do any rules or anything. I don't want to go through every single thing again. Maybe in another video, but you guys just need to remember that by heart. if I got c to the power of x, my f prime of that is gonna be c to the power of x times ln of c. Okay, you guys just need to remember that. And if my function is equal to h of x plus g of x, my f prime, why am I writing equal? My f prime of x is going to equal to h prime of x plus time g prime of x, no, time g of x plus g prime of x times h of x. Now, if I have a quotient rule, a product rules, my f prime of x is going to equal to, wait, I made a mistake. See, I was saying, oof, I need to wake up right here. My f prime of x is going to equal to h of x, x prime of x plus g prime of x. Excuse me for that. So let's go through it again. If f of x is equal to h of x plus g of x, my f prime of x is going to equal to h prime of x plus g prime of x. If my f of x is equal to h of x times g of x, my h prime of x is going to equal to h prime of x times g of x plus g prime of x times h of x. Okay, now let's do the quotient rules finally. One last thing that you guys need to learn. This time, let's put h of x. Right, so h of x up. So if my f prime of x is equal to, my f prime of x is going to be equal to h prime of x times g minus g prime of x times h divided by g of x to the power of 2. Alright, so this is everything you guys need to learn in this video. Oof. In the next video, we're gonna learn how to I'm gonna make a video on how to solve derivations. We're gonna learn derivations problem, and after that, we're gonna see chain rules. We're gonna look deeply how chain rules work, and I hope this was good for enough for you guys, because there was a lot of proofs that we have done. It was very long in my opinion, but if you guys managed to follow me up until this point, you guys are good. Okay, so have a great day and goodbye.